So you guys want to build an 8x8x8 RGB LED cube, huh? Well, it's good. In this video, I'm going to take you back in time and show you the process of building an 8x8x8 RGB LED cube. I took pictures along the way and shot some videos, so I think what I'll do in this video is sort of narrate a slideshow of the build, and we'll talk about different things like why there's so many wires down there. That seems to be a common question. And usually when people look at the cube, the first thing they ask is, how did you solder all those LEDs together? Well, you need the help of a jig. So we'll talk a little bit about this thing that sort of helps you solder everything. And I use the word help lightly because this thing, I don't know, you could probably count how many solder joints there are, but you have 512 LEDs, each with 4 leads on it. Multiply that up, and then all the rails and the anode connections, and then you've got all the wires going through the board here to the bottom, and then the ribbon cables going out, and the ribbon cables go to the cathode control boards, and then the base of all those transistors on those boards are driven by shift register outputs, so there's another 192 wires. It's insane. So let's take a peek, grab a beer, and join me for this reflection. So one of the first things I did was make a little test board here, and this tests the LEDs. And the reason I have 3 LEDs on here is that I've broken out the blue, the green, and the red pin of each of them. Each of them can do blue, green, and red, but I'm just lighting. I have 3 LEDs just showing the blue, green, and red parts. That way, when I test the red, green, and blue of each LED, I can compare it to this LED brightness. Because sometimes, maybe the LED doesn't work at all. That's an easy thing to catch. But the hard thing to catch is if the LED is damaged by not being as bright. So it's a little dimmer, like you might have like kind of a dud LED. Okay, so the longest lead on the LED is the anode in this case, because these are all common anode LEDs. So the way I've been building it is taking the LED, and while facing the leads like this, I make sure that the long lead is counting from left to right. The long lead is in the number 2 place. So I mean, it's the second one from the left. So anyway, and I bend it straight down like this. See that? Okay. Then what I do, I don't bend it at a complete 90 degrees, but anyways, what I do then is put it in the breadboard and test it. So I'm looking at the blue here, and I'm just kind of rolling a 1K resistor here through the cathodes to ground. There it is to green, and there it is to red. So this LED checks out. Alright, and I gotta do this for all 8 LEDs. And it gets easier as you go, especially if you have some TV show on or whatever, and a couple beers. Okay, there's the second one. Okay, I'll probably speed this up a little bit too. Okay, so all 8 LEDs are tested and working. So the next step now is we take the wooden jig here, and we run our 3 wires down through the jig, because what we're trying to do here is solder the RGB leads of the LED to the 3 wires running up and down the column. Okay, and then the anode of the LED, the common anode lead, will be left freely, as you can see from one that's already done here. Okay. This is by far the most tedious part of the build, by the way, because I had to buy insulated wire to do this. This is 22 gauge wire, solid. right from Radio Shack. So what I'm doing here is, let me bring this guy in a little bit closer so you can see what's happening here. So what I'm doing here is bringing this wire out just a little bit longer than the jig, and you'll see kind of why this is done like this. And I strip it a little bit, not being sure not to cut the wire, because if I cut the wire, then I got nothing to grip it as I'm stripping all this insulation off. Now, if I could somehow figure out a way to buy this wire with the insulation already stripped off, I'm sure if I would have searched around on eBay a little bit, I probably could have found it, but I was kind of in a rush. Okay. There we go. Then you can cut the wire. Now you can kind of tell the reason why we're using a jig. You see how the wire's kind of, you know, all bent up and not straight? Well, imagine trying to solder to this, keeping everything in line. You know, the LED cube would turn out like crap. Alright, so what we're doing now is feeding it through one of the little holes I drilled at the top of the jig. Okay. That feeds through, comes out down here. Get in there. There you go. Okay. Now grab these guys here. Bend that wire over on the one side. And then on this end, we can pull the wire tight. And that kind of pulls all the bends out of it. So you pull it a little bit tight. Bend it around. And, you know, kind of pulled that guy out a little bit. It's still a little crooked, but nothing that nobody can tell or notice. And once we start soldering LEDs to it, it'll sort of straighten out a little bit more. Okay. And now we got to do that 2 more times. Okay. And I'm kind of rushing this one so I don't waste too much time. Okay, so now we have 3 wires going up and down the column. And let me show you a little bit of a zoom in on this so you can see. So we have the 3 wires going up and down, and then we'll drop in the LEDs into each one of these little, what's that? Anyway, drop in little LEDs into each one of these little posts here. Okay, so the way we're doing this is we already bent out the anode LED a little bit, so, or anode lead, sorry. Then what we're doing is bending out the R, the G, and the B. I don't know which is which, but it doesn't really matter as long as we build them all exactly the same. So then you have something that looks kind of like that. This is the anode, and then this is the RGB. And then from this now, we can drop these right in to our jig. Let me do one and then I'll show you what it looks like. See? Sounds like there's a party going on out there. Anyway, so what we have here is we're dropping in the LEDs into these little posts here. And then the leads are touching the wires like that. And then we'll solder it like that. Okay, so it keeps the wires straight and it keeps all the LEDs straight. Now I'll go through and do all of them. Okay, so now we have all 8 LEDs dropped into place and are ready to solder. Okay, if you're new to soldering, you're going to get plenty of experience on this project. Okay, so the soldering is done now, and it looks pretty good. I kind of rushed this one so the rods aren't perfectly straight, but it doesn't matter because the LEDs are lying in their little posts, so they will, when I pull it out, they will look perfectly straight. So next is, I got a little box here. It's the garbage box, and we cut all of the extra wire off and we pull it out of this thing. Okay, so let's pull the extra wire that was going through the whole column here, and then we'll cut the wire off the leads. Okay, now this is my favorite part of this. Check this out. Make sure that guy's recording. See, the way the jig works is once all the leads are in, the space in between here is very important so that when you pull this thing out, they all slide up, and then you can very easily pull it right out of there. Okay? And that's how the jig works. Oops. And it's actually, this thing, it looks very fragile, but it's actually pretty durable. So the architecture actually holds up pretty well. Okay, I'm just kind of straightening it out a little bit. Okay? And then the only thing to do next now is cut the extra wire off. And when you do this, be careful that you don't cut too close to the solder joint. Because if you do that, you might actually cut through the solder joint and it'll break it. And sometimes it's hard to detect if you got a cold solder joint, so be careful. And even if you leave a little bit of extra wire on there, it's not going to hurt. But you don't want to leave too much because two of these will be right next to each other. Okay? I'm cutting it pretty close. Anyway, just cut all this off real quick. And I'm even cutting the wire off the bottom, which might not be a smart move right now because I don't know how I'm going to wire into the RGB of this entire column yet. It would have been nice to leave that wire on, and one way to think about it, but because at least then I could poke it into some foam or something and it'll poke through the bottom, and then I can wire into the leads. But we'll figure that out when we get there. Okay, so I wish I could say that once you build all those pillars, all 64 pillars, that you might start seeing the end of this, but you're far from being done. You still have to solder all of those pillars together, and you still have to build all of the circuitry. So actually building the cube, I think, was the fastest part of the whole process, believe it or not. So one thing, a few notes just on that video. Along the way, I did sort of change my technique slightly. So I decided to test every single LED in the bag first. So I sat down and tested every single LED, the RGB. And I also pre-cut all of the wire, which required me to strip all the wire, then pre-cut the wire. Okay. And that was pretty much it there. So I still followed that same technique. But once you build up all the pillars, then the next step is to build the slices in the videos. Not the levels, but if you take like a vertical slice of the cube, all of the anodes are tied together. So you sort of build up this these slices is what I'll call them. And you still cut the wire across, but this time I don't really have a jig to really keep everything in order. So what I did was actually just mark the wire in 1-inch increments, and then I laid out all the pillars on the table and laid this wire with markings on it and soldered all of the anodes to that wire. And I did this 8 times until I built up a slice. Now remind you, all of the slices will be also soldered together. But they don't need to have 8 wires in between. In fact, you just solder, or what I did was I just soldered the outside wires. Okay, so each slice is actually only connected via the 2 outside wires. that might seem a little confusing, so maybe we'll come back to that here in a little bit. So I'm sort of just skimming through my pictures here, make sure I touch on everything. And it's kind of fun to build up the slices because you start to notice how they all, so you can lay them on top of each other, and you start to sort of dream about what the cube is going to look like when it's done. So it's kind of fun. Let's take a quick look at these videos here. I have a few videos here, or maybe just one video, on how to test the slices and sort of what it looks like. Just a quick video here to show you how to test your slices once you get them to this point. So right now I have all 8 of these made up, and they're ready to be soldered together. Okay, so it's very important to test your slices. And I'm calling these things slices, okay? But it's very important to test them at this point, because once you solder them together, it's nearly impossible to get access to the inside LEDs inside the cube. So you should go through and make sure that every LED works. And it's not as bad as it sounds, because the way we have this set up is all of the common anodes are connected per row, and then all of the RGB cathodes are connected per column. So what we do is set up a little breadboard here with a little 1K connected to ground, and then a big long wire connected to the other side of the resistor, and then another wire with a little alligator clip connected onto it, connected right to the 5 volts. So then what we can do is tap right in off the 5 volts to one of the anode row pins, and then kind of sweep our cathode wire here that's connected through a 1K to ground through, and we can just kind of drag this through there and see that every single LED lights up. Okay, and then once you complete a row, see, that was pretty quick, you move your anode alligator clip to the next row. Okay, and sweep that through. Okay, so kind of tedious, not really the thing you want to do at this point of the build, because you're going to be very, very anxious to start soldering all of these together, but it's very, very important to take the time out and test every single LED at this stage in the game, because when you're clipping these leads off, there's a good chance that you could break the solder joint. Okay, so I'm sure I'll find 1 or 2 LEDs that won't light up, and even doing this isn't going to catch everything, because sometimes it's a mechanical type thing, where the LED is just barely touching the wire, and it will light up, but hopefully I'm kind of stressing the columns enough to catch that, but we'll see what happens. So anyways, I just wanted to make that video to show you, and it also kind of helps explain how the connections are made. Really the point of that video is to catch these problematic solder joints early on before it's too late, and trust me, I did find quite a few after testing all of the slices. And then I even found a few even when I soldered the slices together. So once you solder all of the slices together, I don't think I actually have any pictures of that, but you start to sort of see how it was done, and that was a really challenging part of the build. But once you do that, then you have essentially the entire cube assembled. Okay. Now remember in the first video I explained how it would have been a good idea to keep the bottom leads long, don't cut those? Yeah, well, I wish I would have kept those long, because I had to build these little tiny leads with little fish hooks on them. I bent that around with a pair of tweezers, or needle nose pliers, and I actually had to then crimp that onto the bottom of each of the cathodes and then solder those wires onto it. So I had all of these like 2-inch pieces of wire sticking off the bottom of the cube, so that would be 192. So I did that, and then once I had that, I got this foam board, and I sort of pushed the foam board down onto the cube, and all 192 little wires stuck out of the bottom. Okay, and then I acquired some ribbon cable. That was just some cable I had laying around, and then I started soldering the 192 wires to the bottom there, and I started at the top and counted my way down, and I just used right in line with the ribbon cable. So I went looking at the LEDs, there were RGB, 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 and each of them had a number, so it was like 1, 2, 3, 4, 5. And then when I got all the way to the bottom of one row in the cube, I started back up at the top and continued down. So it actually goes, it starts from the top to the bottom, 1 all the way down to, well, if it's 8, what is that, like 24, right? If there's 3 per, so you go all the way down to 24, and then 25 would be the next row over all the way at the top. So that's how I built it, and then I had all of this ribbon cable sticking out, and I even numbered the ribbon cable and sort of put some arrows on it so you could see it, and that took forever to do, okay? And then the next step, of course, was to solder the anode connections. I don't think I actually have a picture of that. I may actually, you might be able to see in one of the pictures, but each level then has a little wire sticking out of it and then goes down into the foam board. As multiple wires. I think each level has like four little wires that stick out and go down into the foam board, so that I could put 5 volts onto each level. Okay, so I used 10 of these proto boards, and I'll put a link in the description, if I remember, for what proto boards I use. These are my favorite proto boards. I use them for everything, and they're pretty cheap too. I think they're only like $1.50 or something, and I buy them from FutureLEC. In fact, all of the components in the cube are essentially from FutureLEC, except the LEDs. I think I bought those from, I bought those off eBay from somewhere. I think I paid about $75 for 600 LEDs. I think that was the cost. You probably will be able to find a better deal than that. I would not recommend buying them, from like a SparkFront or even FutureLEC or DigiKey Mouser, because they'll just pay way too much for them. You have to buy these things in bulk to save money. Okay, so we have 10 proto boards, almost completely populated each, and so we have the three shift register boards, and we have the Arduino control board, which I think I soldered that one last. Well, we have the 3 shift register boards. We have an anode control board, and then the rest are these cathode control boards with the transistors. And I soldered all of the parts to these boards before soldering wires to them, just so they were a little bit more mobile. So I was able to sort of solder them and just kind of laying around and flip them around. It was kind of easy to do it that way. Once I did that, then I soldered all 192 wires from the cube to the cathode control boards, is what I'll call them. And you'll notice as I went, I numbered the transistors. So I went all the way 1 to 192, so it was a little bit easier to track and trace where everything is coming and going. So you know exactly where what LED corresponds to what transistor. And that also helped a lot with the lining these up with the shift registers then, because the NPN transistors, the way I have it, if it goes 1 to 192, it's going like RGB, RGB, RGB. So it can get kind of confusing. Unfortunately, it's kind of funny. You'll notice in some of these pictures there is no 100 ohm resistors, and that's because I suddenly changed my sinking resistor, the current limiting resistor. So anyway, that's why I had to reorder the 100 ohm, and I didn't have them, so I actually soldered everything together, then had to go back and solder in the 100 ohm resistors. Okay, so you could start to see how crazy this was getting. And then, of course, finally, when I got to the last LED, it was just, I celebrated at 192. But the fun was short-lived, because then you had to solder over from the bases of those transistors to the outputs of the shift registers. Okay, and then that's when things got really, really crazy. And then, of course, once I got the 100 ohm resistors, I soldered those in, and you can kind of see where it goes. The red or the green and the blue only have the two 100 ohm resistors in parallel, where the red only has the one, because it is a brighter LED. So I wanted to sort of have an equal balance of color there, of brightness between the 3 LEDs. Okay, so then I started getting everything together, and then it was of course, I didn't have a power supply yet, so I ordered that separately, and I was only able to power it up off of just, you know, like a little cell phone charger type power supply, just a 5-volt supply. Plugged it in, thought everything was looking good, powered it on, and nothing happened. Okay, like nothing. So this is kind of my little disclaimer here in the video. I just want to warn you guys that, you know, if you build this thing and you plug it in and you write the code to it and nothing happens, there is nothing I can do to help you, because it could be a million things wrong with it. In fact, it'll probably be a few things wrong at one time. And it's really hard to kind of catch that. So that's why I really emphasize testing as you go and make sure everything works. So it turned out the first thing that went wrong was I had a dead short between two of my pins on one of the shift registers. So it was shorting out an entire bus signal. I think it was like the blank pin against like the clock pin or something crazy. So nothing happened. So that was the first problem. I fixed that, then I turned it on again, and all the LEDs would flash white. Like they were all on, and then it would turn off. So I actually thought something was wrong with my code, but that couldn't be, because I sort of tested the code out on a single LED. Then all of a sudden I'm poking around, and I ground a part of this circuit with a scope, because I started scoping out signals, and I grounded a part of the signal, and it turned out, and then all of a sudden the LED, the cube started lighting up again. It was kind of crazy. And it turned out to just be a faulty ground between two boards. The scope actually grounded one board. So that was the one problem. So kind of basically, you know, the moral of the story is that, you know, it could be anything, and you might get lucky to find out what was wrong. If I had not grounded that part of the circuit with the scope, I mean, I could have spent days, months, who knows, trying to figure that out, or maybe just give up on the whole thing altogether. So I'm just warning you guys out there. So, you know, like if you build this thing and you come to me in a message, there's nothing I can really do to help you. I mean, as much as I'd like to, but unfortunately, you're kind of on your own with this one. Okay, so anyway, you know, I eventually got it working, up and running, and here's just a few shots. And once I got it working, I wrote a few sample animations, and it was amazing. So you can kind of see here some of the pictures of the cube. But yeah, that was pretty much it. I mean, of course, it took forever to build this thing, but you just sort of have to take it slow and test everything as you go. So hopefully this helps. Thanks for watching, and by the way, next video should be the code video. So thanks for watching.